Okay, the next big topic we attack in trig is it's going to be the inverse trigonometric functions. And the first one you see is the inverse sine function. This is kind of like my definition of inverse sine. I say the inverse sine function, which is denoted by y equals inverse sine of x. That's how you read this, inverse sine of x. Some books, and you might see this later on in calculus, instead of saying inverse sine, they'll say y equals arc sine x. Inverse sine, arc sine mean the exact same thing. So inverse sine x is really defined by the following. Y equals inverse sine x, it really means that sine of y is equal to x. So y equals inverse sine x really means the sine of y is equal to x. For your inverse sine function, y equals inverse sine x, the domain is negative 1 to 1, and the range is negative pi over 2 to pi over 2. So for inverse sine, with these inverse trig functions, I'd kind of like you to think the following. You hear inverse sine. Go ahead and think that the purpose of inverse sine, its job, if you will, is that of angle finder. It's trying to find an angle. And I'm going to take this back to the unit circle. The unit circle is really important. Knowing the unit circle makes so much of trig and later work in calculus much easier. Inverse sine is finding an angle. Its job is to find an angle. Specifically, it's looking for an angle on the right half of the unit circle. It's looking for an angle negative pi over 2 to pi over 2. This is negative pi over 2 to pi over 2. So inverse sine is trying to find an angle on the right half of the unit circle. And next we'll do some examples of finding exact values of inverse sine. Alright folks, first example here, let's find the exact value of inverse sine square root 3 over 2. So keep in mind, inverse sine square root 3 over 2, we're trying to find an angle. We're trying to find an angle that when we do the sine of that angle, we get square root 3 over 2. And we're looking specifically for an angle that's on the right half of the unit circle. What I just showed you, inverse sine is finding an angle on the right half of the unit circle. So when I think of the right half of the unit circle, sine, I'm thinking of a y-coordinate on the unit circle. I'm thinking of a y-coordinate of square root 3 over 2. And that occurs at pi over 3. So inverse sine of square root 3 over 2 is pi over 3. And think about the reason why. Go back to the definition. Inverse sine square root 3 over 2 is pi over 3 because when you do the sine of pi over 3, you get the square root 3 over 2. Again, we're only looking for an angle on the right half of the unit circle when we're doing inverse sine. Just the right half of the unit circle. That's it. Let's do another one. Let's say you're asked for the exact value of inverse sine of 1/2. So here we go. Inverse sine. Inverse sine. It's trying to find an angle. Its job is angle finder. So find an angle on the right half of the unit circle. Find an angle on the right half of the unit circle that the sine of that angle is 1/2. And we would get the inverse sine of 1/2 is pi over 6. This is all coming from the unit circle. Quick note before we look at the next part of this example. Your answers here have to be in radians. Look at the definition. The definition tells you the stuff is in radians. We're talking about real numbers here. Real numbers. Radians are real numbers. So if you were to tell me the exact value of inverse sine of 1/2, if you were to tell me that that is 30 degrees, technically that is wrong. has to be in radians. Next one. Inverse sine of negative 1/2. Okay, now we have to be careful here. I know inverse sine is looking for an angle on the right half of the unit circle. So I know I'm looking on the right half of the unit circle. I'm looking for an angle. When I do the sine of that angle, I get negative 1/2. I know this point right here on the unit circle. That point is square root 3 over 2, negative 1/2. I know that point is, it's telling me what the angle should be. So I need to know this angle. And we might be tempted to say 11 pi over 6, and that would not be correct, because 11 pi over 6 is not in the interval negative pi over 2 to pi over 2. Here's 11 pi over 6. It's this angle measurement. It's that angle right there. And it is true that the sine of 11 pi over 6 is negative 1/2. That is true. But it's not. 11 pi over 6 isn't between negative pi over 2 and pi over 2. Think of a number line. Here's negative pi over 2. Here's pi over 2. 11 pi over 6 isn't between those two values. 11 pi over 6 is way out here somewhere. So you really need to give that angle measurement. That will be a negative angle. It's actually coterminal to 11 pi over 6. All this goes back to like the very first week, the very first material you learned. So that negative angle that's coterminal with 11 pi over 6 is negative pi over 6. So inverse sine of negative 1/2 is negative pi over 6. Those are the ones that we have to be careful with, is inverse sine of a negative number. Final one here. Let's say you're asked for inverse sine of, say 2. Can't do it. That number is larger than 1. There is no angle that exists that when you do the sine of that angle, you'll get 2. There's no angle that will make this valid. Remember, the largest value that sine could ever have is 1, and the smallest value that sine could have is negative 1. So when someone says inverse sine of 2, and you're thinking, well, the job of inverse sine is to find an angle, you should say, well, wait a minute. There is no angle that when I do the sine of that angle, I get 2. So this is not possible. Just be on the lookout for that. That's not possible. Before I go on to talk about the inverse cosine, because we have to look at that inverse trig function, getting a good understanding of what we're doing here with inverse sine, that's going to pay off later on when we learn something called the law of sines. That's how we solve some non-right triangles. So just let's try to get a handle on this. It's laying the foundation for future work. All right, hey, the next inverse trig function we look at is the inverse cosine function. Here's kind of my working definition of inverse cosine. So the inverse cosine function, which is denoted y equals inverse cosine of x, and then some books, and also you might see this in calculus, instead of saying inverse cosine, they may say y equals arc cosine x. So inverse cosine and arc cosine, they mean the same thing. It's defined to be the following. Y is inverse cosine x means the cosine of y equals x. So when you see y equals inverse cosine x, it means the cosine of y is x. For the inverse cosine function, the domain is negative 1 to 1, and the range is 0 to pi. So hey folks, just like with inverse sine, it's okay to think that the job of inverse cosine, it has the same type of job as inverse sine. Its job is to be an angle finder. Now remember, inverse sine is finding an angle off the right half of the unit circle. Inverse cosine is finding an angle off the top half of the unit circle. Comes from this part here, 0 to pi. So inverse cosine, its job, angle finder. Where's it looking for the angle? It's looking on the top half of the unit circle. So let's do an example of finding some exact values involving inverse cosine. All right, here we are. Let's find the exact value of inverse cosine square root 3 over 2. So here's what I'm thinking. Inverse cosine, trying to find an angle. Inverse cosine is trying to find an angle on the top half of the unit circle. So I'm trying to find an angle on the top half of the unit circle. Then when I do the cosine of that angle, I get square root 3 over 2. And that angle would be pi over 6, because the cosine of pi over 6 is square root 3 over 2. Let's do another one. Let's say we're asked to get the inverse cosine of 1/2. Let's think. We're looking for an angle on the top half of the unit circle. Inverse cosine looks for an angle on the top half of the unit circle. We're trying to find that angle on the top half of the unit circle. And when we do the cosine of that angle, we get 1/2. That angle would be pi over 3. Okay. Hopefully now, you're starting to see the importance of the unit circle. If you know the unit circle, you know those points, coordinates of those points on the unit circle. It makes this stuff a pretty easy task. Let's try another one. Let's try to find the exact value of inverse cosine negative square root 3 over 2. Now think, folks, we're looking, inverse cosine, we're looking for an angle. We're looking for an angle on the top half of the unit circle. So if I think of the top half of the unit circle, well, I think this point that's about right here, and the coordinates of that point are negative square root 3 over 2, 1/2. That's gonna be the key in getting this. So what angle intersects that point on the unit circle? What's the measure of that angle? Well, hopefully we know our unit circle, and we know that angle is 5 pi over 6. Unit circle makes it friendly. Let's do one more. Just to keep us honest here. Just to keep us honest, what's the inverse sine of negative square root 3 over 2? Remember, inverse sine is looking for an angle on the right half of the unit circle. So inverse sine is looking for an angle on the right half of the unit circle. I think this point right here, that point has coordinates of 1/2 negative square root 3 over 2. That's the point for me here. This angle right here, that angle will be the answer to what inverse sine of negative square root 3 over 2 is. And that angle happens to measure negative pi over 3. So I thought I'd toss D in here doing an inverse sine to keep us honest, to keep us remembering. Inverse sine finds an angle on the right half of the unit circle. Inverse cosine is finding an angle on the top half of the unit circle. Hey folks, let's quickly talk about how we approximate these inverse trig functions we've seen so far, inverse sine, inverse cosine, using our calculator. I will use a calculator if I'm giving a value here that isn't something that I know off the unit circle. I mean, the points I know on the unit circle match up with very special angles. Pi over 4, pi over 3, pi over 6. And I know those coordinates of those points that go around the unit circle. All I know is, since this is dealing with inverse sine, all I know is that's some y coordinate on the unit circle. I know inverse sine is finding an angle out there on the right half of the unit circle, and I think this angle would be in quadrant 1 because that's positive, and y's would be positive in quadrant 1. But I don't know exactly what that angle is off the top of my head. I don't have that much free time on my hands. So when I'm given a value here that I don't know off the unit circle, I'm going to use my calculator. So make sure you have your calculator in radian mode. Dealing with real numbers here. So your calculator's in radian mode, and if you do inverse sine, so that's like second sine, if you do inverse sine of 0.853, you should get 1.0217. 4 decimal places is plenty. Likewise, if you're asked to do inverse cosine of, let's say 0.231. Again, that's not a number I know off the top of my head on the unit circle. Since it's inverse cosine, I do know that's an x coordinate. I know inverse cosine is finding an angle on the top half of the unit circle, but I don't know off the top of my head what that angle is. I'm going to use my calculator here. So I'd use my inverse cosine function. Again, make sure I'm in radian mode. And when I do this on my calculator in radian mode, so when you do it, you should get inverse cosine of 0.231 is 1.3377. And again, rounding it to 4 decimal places should be plenty. Now let's not be deceived here. Say you're asked to find inverse cosine of 1.324. You can't do that. This number is more than 1. You can't do it. You can't get an angle that when you do the cosine of that angle, you get a number larger than 1. So this is impossible. And if your calculator's in radian mode, and it's also in real mode, if you try to do this on your calculator will give you an error. It says something like error domain. That's larger than 1. That's what your calculator's trying to say. So that's a quick look at how to evaluate some of these things using your calculator. Next thing we're going to look at is our inverse tangent function. Alright, here we are with the inverse tangent function. My working definition for the inverse tangent function is that the inverse tangent function, which is denoted y equals inverse tangent x, and again, for future work in calculus, you may see it written as y equals arctan x. Inverse tangent and arctan are the same thing. It's defined by, y equals inverse tangent x really means the tangent of y equals x. And it's looking similar to the definitions for inverse sine and inverse cosine. Now for your inverse tangent x, for that function inverse tangent x, the domain is all real numbers, and the range is negative pi over 2 to pi over 2, not including the endpoints. So that's why I have parentheses around them, because those endpoints are not included. Just like with inverse sine and inverse cosine, I think, and I'd like you to think, that the job of inverse tangent, it is an angle finder. That's what it does. It finds an angle. Where's inverse tangent looking for the angle? Well, it looks like in the interval negative pi over 2 to pi over 2. It's looking for the angle on the right half of the unit circle, but notice I put open circles at those endpoints, not including those endpoints. That matches up with the parentheses here. Folks, I didn't put on my chalkboard here, when we did inverse sine, I didn't put the graph of the inverse sine function. nor did I put the graph of the inverse cosine function. I am going to put up the graph of the inverse tangent function, because this graph of the three big inverse trig functions, the graph of inverse tangent will be important later on in your math career. It will be important when you get into calculus. So I'm just putting this up here for your future work when you go on into calculus. And this is the graph of the inverse tangent function. It looks something like this. There's a horizontal asymptote at pi over 2 and a horizontal asymptote at negative pi over 2. And that's a very rough, quick sketch of what the graph of inverse tangent is. Won't be important in trig, but trust me, that will be an important graph in calculus. Hey, let's finish this off quickly. You're asked to find inverse tangent of 1. Think. Inverse tangent's trying to find an angle. It's trying to find an angle on the right half of the unit circle. When you take the tangent of that angle, you get 1. So inverse tangent of 1 is pi over 4. I'd really, really like you to know that one. Likewise, inverse tangent of negative 1. It's looking for an angle. That's the job of these inverse trig functions. Angle finder. Inverse tangent's looking on the right half of the unit circle. It's looking for an angle that when you do the tangent of that angle, you get negative 1. This would be negative pi over 4. These are two that I'd just like you to know. Just know them. And finally, how about inverse tangent? Inverse tangent of 0. Well, it's looking for an angle on the right half of the unit circle. That when you do the tangent of that angle, you get 0. And inverse tangent of 0 is 0. So those are the three that I'll kind of focus on in the inverse tangent world. Now when you're, this is a quick overview of the three main inverse trig functions. So hopefully it makes some sense. I hope you're starting to see the power of that unit circle. I really can't stress how important that unit circle is. So know where inverse trig functions, know where they're looking for the angle. Inverse sine is looking for an angle on the right half of the unit circle. Inverse cosine is looking for an angle on the top half of the unit circle. And your inverse tangent, it's looking for an angle on the right half of the unit circle. That's it. Thanks for watching.